Hello, everybody. Today we're going to work with a figure called a trapezoid. A trapezoid is a quadrilateral, means it has four sides, as you can see, and it has one pair of parallel lines, and that's going to come in handy in a minute. Remember, those lines go on forever and never end. They're called parallel lines. Now we're going to find the area. That means how many total squares are inside. Now, if you had your graph paper, I know this is a little bigger because it's a smart board, but each one of these would be a centimeter. So one of these on your graph paper would be 1 centimeter, and 1 centimeter square, 1 square centimeter. That's how you say it. Okay? Now, we could count them and we could get an estimate. But if you think about it, hey, here's one, 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 here's one. There, uh-oh, what's this? That's like maybe a half. Okay. Oh, look at this. What is this? Like, 7/8 of it. This one looks like a quarter. Oh my goodness. It would be too hard to count these little pieces. So let's not do that. Let's do something that we know is going to work. There's two ways we're going to do this. We're going to do this the mathematical way with the formula, and let me bring the formula up for you. There is a formula. This is what I used when I was a kid. Okay, let me move this over. Area equals, here's my equal sign, 1/2 h, that stands for the height, in parentheses, b1. Probably think, what is b1? Well, I'm going to show you. Plus b2, and that's our formula. Okay? So here's what we're going to need to do. We're going to have to replace the letters with some numbers. Okay. Well, the base 1 and base 2 is basically the parallel lines. And if you think about this, instead of B1, if I was teaching this years and years and years and years and years and years ago, which I did, parallel lines, here's my parallel lines, instead of B, you know what I would have probably changed it to? I probably would have changed it to, and I'll flip this and you're going to see it, I probably would change it to a P. Because we could consider this P1. And then this guy, the same thing. If I turned him over, okay, it looks like a Q now, but if I turned him over and flipped him, that's a P. So it would be like P1 plus P2. Now, to me, that makes sense because that would be your perpendicular lines, even though we called it base 1 and base 2. I better put that back before I get in trouble with some mathematicians. They probably wouldn't like that. But to me, it makes sense. Okay, let's put some numbers here. The height, remember we talked about the dotted line. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 8 high. And the base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's on the bottom. That's one of the B's. And the top B, the top base, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 of these guys. Now that's all the numbers we need. We do not need this side or this side. We do not need those because we're finding the area inside. If we were finding a perimeter, that'd be a different story. Okay, let's replace the letters with the numbers. It's very simple. Let's go with 1/2. We'll keep him. He's our constant. The H is Mr. 8. Put him here. We don't need a sign here because we know it's multiplying. Okay? We can put him here anyway. It's okay. And let's go our parentheses. There's our 8. Our B1, we can say, is 16. And our B2 could be 10. It's going to be. Now, you could replace 16 and 10 because if you actually flip this whole figure upside down, the 16 would be on the bottom and the 10 would be on top, so it doesn't matter. Okay, let's get rid of my parallel lines here, and let's do the math. 16 plus 10 is 26. That's easy. Okay, parentheses first. Multiply next. We can do 1/2 of 8. That's simple. That is just 4, half of 8. So now we got 4 times 26. And we can do this, remember this way? 24, keep the 2. 2 times 4 is 8, 9, and 10. There's 104 squares in here, and we'll call them centimeters. All right. Let's try it a different way. Let's try it without a formula and see how it works. Okay, so just remember 104. I'm going to put this up here so I don't forget. 104. All right. Let me erase all this madness. Sorry. Almost erased. And let's do it by cutting the piece in half. Actually, into 3 sections. Actually, 2. Watch. Watch what I do. Let's take my green. Okay, so we know that this was 10 here. And then we went up 8. We can go over 10 again and down 8. If we take that out, kids, we have a rectangle that is an 8 by 10. Let's keep it in here, okay? Let's keep it in here. Now, let's highlight it, if I can. I think I can, with one of my special pens. Let's see if there's something a little bit better. Oh, keep that. I'll just color it in. We're going to find the area of this rectangle. And it's going to be pretty easy. Pretty easy, pretty easy. Because we know that from here to here is 10. And we know that the height was 8. So that is an 8 by 10, which is a total of 80. So there's 80 in here. 80 in here. Let me just go to the outside. There's 80 squares in there. Now watch what I do now. I'm going to take the 2 triangles out. Try to do it as nice as I can and kind of fast. Okay, there's my triangle. Let's take him out. Let's put him over here. Okay. Now we know the area of a triangle. Oh, I did this one. He's gone. I moved him over. Let's take this guy right here. Let's take him apart and put him over here. But what we have to do here, though, is we have to flip him a little bit. So let me move this over, get rid of this mess. Let's move this guy over. Nope, wrong guy. Wrong guy. I think I have to do it again. Let's move just a little bit over where we had him to begin with. Okay, that's better. All right, let me copy him. He's 3. There's my hypotenuse. That's a word for you, huh? So I'm going to take him out, and I'm going to flip him. Turn him upside down. I forgot to flip him. Flip, left to right. Come on. And I'm going to stick him right here. And if you notice, kids, my 2 triangles here and here that I just took out and put over here becomes a rectangle. 1, 2, 3, 2, 4, 6, 8. And you guys know that 3 times 8 is a total of 24. So, this rectangle was 80. This rectangle is 24. And I think 80 and 24 is 104. Doesn't that equal the same thing? How about that? All right. So now you guys know how to find the area of a trapezoid. That's 2 ways. Okay. Have a great night.